Picture a jaguar prowling through the Pantanal, while invisible ears listen for poachers and chainsaws in the shadows.
Imagine microphones capturing birds and monkeys as an artificial intelligence system decodes their songs and warns of danger.
Coral reefs to deep-sea trenches, computer vision now maps ecosystems and spots illegal fishing instantly worldwide.
Welcome to our journey into Bezos Earth Fund's bold experiment with artificial intelligence for climate and nature.
Today, we explore how 15 visionary teams across 5 continents are harnessing AI to protect wildlife and fight climate change.
From monitoring jaguars in Brazil's Pantanal to decoding whale songs, these projects bring technology and biology together beautifully.
We also confront the elephant in the room. Your hosts are digital voices, but our passion for conservation is real.
As our voices guide you, we will meet scientists, communities, and AI tools that listen, see, and learn from nature.
Together, we will unpack myths about technology's environmental footprint and celebrate the innovations making conservation smarter and kinder.
By the end, you will see how responsible AI can help endangered species survive and ecosystems thrive, while empowering people. Jeff Bezos pledged $10 billion to climate and nature, and his Earth Fund continues to launch audacious projects. This story focuses on a new $30 million investment supporting artificial intelligence solutions for biodiversity, climate, and food security. The AI for Climate and Nature Grand Challenge began in 2024 to find breakthroughs that make environmental action smarter. 15 teams from every corner of the globe were selected to scale up AI tools with up to 2 million each. They represent universities, conservation organizations, and biotech nonprofits working across Latin America, Africa, Asia, Europe, and North America. Why turn to AI? Because scientists warn we are living through a mass extinction unfolding over decades rather than millennia. Ian Owens from Cornell says, "We simply don't know how most wildlife populations are faring in remote, biodiverse regions." Traditional monitoring relies on human eyes and ears, but that method cannot cover entire rainforests, reefs, or deep oceans. The grant funds are unlocking the power of bioacoustics, listening to nature's voices to learn who is there and when. Cornell's project will deploy edge computing recorders across Guatemala's Maya Biosphere Reserve and Brazil's Pantanal, analyzing sounds in real time. These devices detect bird songs, primate calls, gunshots, and chainsaw noises, sending instant alerts to rangers and conservationists. By learning the daily rhythms of animals, scientists can see population trends and respond quickly when illegal activity threatens wildlife. Audubon will create a community-powered acoustic network across Latin America, empowering local people to track bird migrations and abundance. Such projects support ecotourism and research, inviting everyone from scientists to students to listen to forests and wetlands. Underwater, computer vision models are being trained through the MERMAID platform to identify coral species from diver photographs. Mapping corals helps scientists find reefs that tolerate warming and bleaching, so these refuges can be prioritized for protection. The Nature Conservancy's initiative puts small cameras on fishing vessels and runs algorithms directly on board to flag illegal catches. By analyzing catch footage in real time, authorities can intervene immediately and prevent unlawfully caught fish from entering markets. Revive and Restore will use machine learning to assemble genomes quickly and advise managers on genetic rescue plans for endangered species. These tools democratize genomics by turning complex data into clear recommendations, empowering field biologists to act before species vanish. At the New York Botanical Garden, computer vision models trained on millions of herbarium images will identify plants and flag unknown specimens. This accelerates botanical surveys, revealing new species and helping conservationists focus on areas with many rare plants. Meanwhile, deep-sea scientists deploy autonomous vehicles and sensors to gather imagery, AI then classifies coral gardens and seamount ecosystems. The Deep Vision project aims to map vulnerable habitats and discover unknown life forms, guiding sustainable ocean policy and conservation. All these initiatives rely on collaborations with tech giants like Amazon, Google, Microsoft, and NVIDIA, which provide computing power and expertise. Local communities play a pivotal role. Sensors and cameras are often hosted by indigenous people, rangers, fishers, and citizen scientists. Their participation builds stewardship, provides jobs, and ensures that AI tools respect local knowledge and ethical considerations. Dr. Amen Ra Bashariki, Director of AI at the Earth Fund, stresses that responsible development, guided by science, yields positive planetary impact. These early segments set the stage. Soon we will dive into data, debunk myths about AI's footprint, and spotlight specific projects. Remember, this is a decisive decade. Together, we can harness innovation and empathy to safeguard the planet's extraordinary biodiversity.
Now, let's dive into the data and confront common myths about artificial intelligence and conservation. Together, across the planet, biodiversity is plummeting. Ecologists estimate we are losing species faster than at any time since the dinosaurs. Yet, some people worry AI itself is wasteful. Huge models devour electricity and training data, leaving a heavy carbon footprint. Scientists answer that careful design matters. Edge devices process data locally, reducing cloud transmissions and saving energy dramatically. Even training large models, like natural soundscape foundations, can be efficient when powered by renewable energy and optimized algorithms carefully. Let's examine the Cornell Lab of Ornithology's initiative. They are developing a wildlife listening network with edge computing recorders worldwide. These rugged devices will be deployed in Guatemala's Maya Biosphere and Brazil's Pantanal, two of the world's richest ecosystems today. Powered by solar panels and low-power chips, the sensors record and analyze sound on-site without constant internet connections required. Custom deep learning models recognize species calls and differentiate them from chainsaws, gunfire, or truck engines instantly now. This system can warn rangers within minutes, giving them a chance to intervene before poachers or loggers disappear completely. Over time, AI builds a library of vocalizations. Scientists can track population trends and study migration patterns with unprecedented detail too. Audubon's Latin American project applies similar technology, but emphasizes community participation and knowledge sharing beautifully, empowering locals. Residents help install acoustic sensors in bird habitats, collect data, and use it to manage forests, tourism, and science locally. The outcome is more than numbers. It fosters pride in protecting birds that migrate from these communities to your own backyard too. Moving to the seas, the Wildlife Conservation Society is training algorithms with thousands of underwater photos from divers worldwide today. Their open-source MERMAID platform integrates dive surveys and images to build coral species classifiers with impressive accuracy scores quickly. Maps of climate-resilient reefs help managers prioritize refuges for protection, aligning with global 30 by 30 ocean preservation goals efforts. Citizen scientists, including divers and snorkelers, upload photographs through apps, turning conservation into an interactive adventure for everyone involved. Now consider illegal fishing. Billions of dollars of catch are stolen each year, threatening marine species and honest fishers everywhere. The Nature Conservancy's pilot uses cameras and onboard computer vision to identify species and detect suspicious activity in real time aboard. Processing data on the vessel means officials can intercept illegal fishing before boats dock and catch enters supply chains anywhere. Beyond policing, such monitoring builds trust in seafood markets, ensuring consumers can choose sustainable fish with confidence globally today. Revive and Restore's Genome tools address threats at the genetic level. Many endangered animals suffer from inbreeding and low diversity. Automated assembly of genomes that once took months now happens in hours, opening the door to timely rescue plans everywhere. The AI Conservation Advisor sifts through genetic data to highlight populations at risk and suggest crossbreeding or translocation strategies precisely. By partnering with the U.S. Fish and Wildlife Service, they plan to test these tools on 60 endangered American species soon. The New York Botanical Garden tackles a different puzzle. Millions of plant specimens awaiting identification, and many species still undescribed today. Deep learning models trained on herbarium photos can recognize leaf shapes, veins, and textures, turning botanist tasks into minutes instead. When the system spots an unknown pattern, it alerts researchers who can investigate potential new species and prioritize conservation efforts. The Deep Vision Project reveals another frontier, mapping abyssal habitats we rarely see but urgently need to protect together. Autonomous submarines glide over seamounts and cold water coral gardens, capturing imagery for AI to classify and map precisely. This knowledge informs marine protected areas, guiding negotiators working on treaties and regulations for deep-sea mining and conservation globally. Other awardees broaden the scope. The University of Witwatersrand's Finecast uses AI to forecast weather for African farmers accurately. By predicting rainfall and drought, Finecast helps communities plan crops, reducing hunger and pressure on forests and wildlife greatly. At Yale University, researchers model how ocean conservation interventions can enhance carbon sequestration, linking biodiversity to climate mitigation directly. Delft University explores neural networks for cultivated meat production, while the University of Leeds targets food waste conversion into protein sustainably. These projects address food security, which is deeply linked to habitat loss. Feeding people sustainably protects forests, rivers, and grasslands long-term. A common myth is that AI will replace rangers, farmers, and fishers. In reality, it augments human capabilities and respects local leadership. Another myth is that algorithms alone can save nature. Without community stewardship and policy change, technology is powerless completely. Partnerships with Amazon Web Services, Google, Microsoft, and NVIDIA provide computing power, cloud credits, and mentoring to the grant recipients today. Observers sometimes worry that philanthropic tech funding furthers corporate agendas. The Earth Fund insists that projects remain open and community-driven always. The Challenge's first phase awarded $50,000 to 24 innovators. Next, it selects 15 to receive 2 million grants. Each team will implement solutions over 2 years, reporting results and sharing data with the global conservation community transparently. Another misperception: AI systems are always expensive and intrusive. Many use affordable microphones and filter out human speech to protect privacy. To wrap up this data segment, remember that AI is a tool. Its impact depends on values, policies, and collaborative spirit. As we turn from data to discussion, let's reflect on the ethics of using machines to listen to forests and watch the sea. Some critics fear that technology could deepen inequalities, embedding biases into conservation and excluding people who live closest to nature. I believe our first responsibility is to ensure that artificial intelligence amplifies local voices rather than replacing them. That means sharing decision-making power, respecting indigenous land rights, and designing systems that are transparent and accountable. A ranger in Guatemala should understand how an algorithm flags a chainsaw, and a fisher in the Pacific should have a say in monitoring rules. Without trust, machines become surveillance tools. With trust, they become allies. What do you think makes technology ethical?
Listening to these stories, I'm reminded that AI doesn't work in a vacuum. The only reason an acoustic network in the Maya biosphere matters is because rangers, scientists, and families use the alerts. When we think about fairness, we need to ask whether local communities have access to the benefits. In Latin America, for example, bird sound sensors double as education tools and eco-tour guides. Women and youth gain new skills by maintaining hardware and analyzing calls. In the Pacific, fishers collaborate with nonprofits to shape camera rules. For me, empathy means designing with people, not for them. As a viewer, do you agree that technology should empower rather than control?
There is another side to this conversation: surveillance, and exploitation. History shows that new technologies are often deployed without consent, from colonial mapping to modern data mining. Deep-sea mapping could be used to locate resources for extraction rather than protection if governance is weak. Algorithms trained on indigenous knowledge could be appropriated by corporations unless safeguards exist. That is why open data, transparent algorithms, and strong legal frameworks are essential. People who share land and waters must have the right to access and audit these systems. Transparency builds trust and prevents misuse. Ethical guidelines must evolve as technology changes. Would you support a global charter to protect data rights for nature stewards?
Ultimately, the key lesson from our debate is balance. Tools like underwater cameras and acoustic networks offer windows into hidden worlds, but they cannot substitute for wisdom born of lived experience. Conservation succeeds when scientists, local leaders, and technologists co-create solutions and share credit. So as we move into our case studies, think about how each example we share embodies collaboration. Listen for the voices of rangers, divers, fishers, and geneticists working together. By questioning and learning, we become better guardians of Earth. And please keep the conversation going in the comments. Your questions and insights help guide our channel's mission. Your perspectives make this space vibrant. In Guatemala's Maya Biosphere Reserve, rangers used to rely on occasional patrols to spot signs of poaching. Now, a network of acoustic recorders built by Cornell's team listens to the forest day and night. When a chainsaw revs or a gunshot rings, the device flags the noise and sends a satellite message. In one recent incident, the alert allowed park rangers to intercept illegal loggers before they felled an ancient mahogany. The system also hears the calls of howler monkeys, scarlet macaws, and jaguars, giving biologists insights into where animals roam. Communities living around the reserve have embraced the technology. Women trained to maintain sensors talk proudly about protecting their heritage. In Brazil's Pantanal, a similar setup tracks jaguars and giant armadillos. Here, cattle ranchers cooperate with scientists because they understand healthy ecosystems support their livelihoods. Together, these early successes show how AI complements human vigilance and builds trust between conservationists and local people. These projects are also building a foundation model for natural soundscapes, analogous to a large language model, but trained on wildlife calls. With this tool, conservationists can recognize species across continents and even detect seasonal changes, like when migratory birds arrive. In the crystalline waters of the Coral Triangle, scientists and citizen divers work together to document corals. Using waterproof cameras, they capture images of branching staghorn corals, brain corals, and delicate fans. These pictures are uploaded to the MERMAID platform, where computer vision algorithms learn to distinguish over 100 species. The goal is not just to label corals, but to map which reefs are resilient to heat and bleaching. In the past decade, unprecedented marine heat waves have killed vast swaths of reefs. Yet some pockets remain vibrant, filled with fish and invertebrates. By identifying those refuges, conservationists can prioritize them for protection and restoration. The project also empowers local dive operators. Their businesses depend on healthy reefs, so they are eager to contribute data. One group of divers in Indonesia has logged thousands of photographs, turning their weekend hobby into a scientific contribution. Another team in Fiji uses the maps to lobby for new marine protected areas. This synergy between AI and grassroots action illustrates how technology can accelerate marine conservation and support sustainable livelihoods. It feels like hope under the waves. Not all conservation stories take place in sunlit forests or shallow reefs. Some unfold thousands of meters below the surface, where sunlight never penetrates. The Deep Vision project is sending autonomous vehicles equipped with lights and high-resolution cameras into these abyssal zones. They drift over sponge fields and cold-water coral gardens, capturing images of creatures that most people have never seen, from bioluminescent jellyfish to strange deep-sea octopuses. Back on shore, researchers feed the footage into machine learning algorithms that classify habitats and reveal patterns. Already, they have identified potential hotspots rich in life, information that can inform international treaties on seabed mining. AI is also reshaping our understanding of genetics. At Revive and Restore's lab, scientists are using machine learning tools to assemble genomes for endangered species at unprecedented speed. For example, they recently assembled the genome of a tiny desert fish in days rather than months, and used it to identify populations suffering from inbreeding. By pinpointing where genetic exchange is needed, managers can design captive breeding or translocation programs that maintain diversity. Combined with bioacoustic and imaging advances, genomic AI could give threatened species a fighting chance before it is too late. Our community is the heart of this channel. We recently received a thoughtful comment from Maria in Costa Rica, who wrote that our video on jaguars inspired her to join a local conservation group. Stories like Maria's remind us why we produce these episodes. We want to amplify your voices and feature the creative ways you engage with wildlife. In the coming weeks, we will showcase photos and stories from subscribers who are deploying inexpensive audio recorders in their backyards or volunteering on reef surveys. If you have a story to share, please email or comment below. We might feature you in a future spotlight. Your enthusiasm motivates our team. We appreciate every like and share.
Another viewer, Jamal from Kenya, told us he installed a bioacoustic recorder near his farm and was amazed to hear rare frogs calling at night. His recordings are now contributing to a database that will inform wetlands conservation. We are humbled by how technology brings people together across continents. Whether you are in Miami or Nairobi, you can participate in global biodiversity monitoring. We invite educators to use our videos in classrooms and encourage students to analyze sound recordings or classify coral images. Building a community of citizen scientists helps us grow this channel and expands our collective impact. Keep tagging us in your posts, and we will feature your work.
As our audience grows, we want to ensure that this channel remains a space for constructive dialogue. We welcome constructive criticism, questions, and new ideas. Some viewers have asked how they can volunteer with projects mentioned in our videos. We plan to create a resource page linking you to organizations that need citizen scientists. Others have suggested hosting live question and answer sessions with researchers. We love that idea and will announce upcoming streams soon. The success of this channel depends on your engagement, so please subscribe, share with friends, and continue to ask smart questions. Together, we can build a global family of wildlife guardians. Your support allows us to tell more stories.
Peering ahead, the next decade will bring even more sophisticated tools. Imagine sensors no larger than a grain of rice that can be placed on insects to track pollination across farms. Researchers are developing generative models to simulate ecosystems and test conservation strategies virtually before touching the field. Digital twins of forests could predict the impact of logging or climate change. Likewise, new satellites will provide high-resolution imagery of remote areas, and algorithms will fuse these views with on-the-ground recordings. Finecast may evolve into a global forecasting system to help farmers everywhere adapt to extreme weather. Our responsibility is to ensure these innovations serve life, not profit alone. The future of AI for conservation also hinges on governance and education. We need open-source platforms so that scientists in low-income countries can access cutting-edge models without prohibitive costs. Training programs must be inclusive, bringing more women and people of color into AI and conservation fields. We see young students using machine learning to identify whale songs, and school groups raising funds for coral nurseries. With responsible policies, AI could help achieve global biodiversity targets, like protecting 30% of Earth's land and sea by the end of the decade. It could also help reverse population declines and restore ecosystems. Hope is powerful when paired with knowledge and action. As we close, remember, that artificial intelligence alone cannot save the planet. It is a tool that becomes powerful when guided by ethics, community leadership, and scientific wisdom. The Bezos Earth Fund's investment is planting seeds, but their growth depends on our collective care. Whether you are a student, a diver, or a policymaker, your actions matter. Use your voice to advocate for conservation, support projects you believe in, and join us on this journey.